Good morning, my dear students. Now today we are going to discuss about class 10 physics. Today topic is Osterd experiment. Osterd is a scientist. What is the experiment? This one we will study that one. Osterd was doing the experiment about the circuit. When he was experiment about this circuit, current circuit, at the time, unfortunately, he kept a magnetic needle near the circuit, near the electrical circuit, near the electric circuit. So, when he kept the magnetic needle near the electric circuit, which is parallel to this electric circuit, unfortunately he observed that this magnetic needle get deflect. Learn this one. When he observed this one, again he changed the direction of current. When the direction of current changed, again the deflection also happened in other side. Deflection also changed. That means in this case he came to know that, and he proved that experiment. That experiment is what is now when current is flowing through a conductor. At the time, around the conductor or around the wire, magnetic field will be created. Which one? Magnetic field will be created. How he came to know? Just see here. When the magnetic needle is kept near the electrical circuit, at that time magnetic needle can deflect. So when this magnetic needle will get deflect? When if there is some magnetic field is there. If magnetic field is there, then only magnetic needle starts to get deflect. That means from this experiment, he came to that when current is flowing through a wire or a conductor, then around this conductor or around the wire, magnetic field will be created. Clear this one? Then we will discuss the direction of deflection. Direction of magnetic field, direction of magnetic field on magnetic needle with occurrence to current. So there are some rules are there. First rule is known as Ampere rules. Ampere swimming rule. This is known as Ampere swimming rule. So what is Ampere swimming rule? Generally, when suppose this is one pond or river pond suppose. So when we are swimming, that means during this swimming, our body is parallel to this ground, which is parallel to the pond. That means in this case, suppose this is our head, this is our leg, and this is our hand. So in this case, suppose current is entering through our feet. Then this current passes through our head. This is our head. So if current is entering through our feet and outgoing through our head, so at that time this magnetic field, direction of magnetic field is produced through left side, from right to left. This is our right hand, this is our left hand. So in this case, it will start to deflect towards left side. So this is Ampere swimming rules. Another is known as snow rule. Snow rule. What is snow rule? Snow means S means in this case this is south, N means this is north, and W means this is west. So in this case, suppose this is south, north, east or west. When current is passing from south to north, when current is passing from south to north, at that time deflection of magnetic field, the direction of magnetic field is towards west. That means direction of magnetic field will start deflected, or direction of magnetic field will be west to east. That means this is also right to left. That means this is also left side deflection. That means in this case, this Ampere swimming rule and snow rules, these two rules are equal to each other. In this case, what is happened when current is enters through his feet and passes through his head. At that time, the direction of magnetic field is towards left side. So in this case also same thing. When current is passes from south to north direction, in this case also the direction of magnetic field is towards left side, west to east. That means it is also towards left side. So this is known as snow rule and Ampere swimming rule. Next, we will study about magnetic field is produced through a straight conductor. Magnetic field is produced through a straight conductor. See here. Magnetic field is produced by straight conductor. Straight conductor. See here. Suppose this is one straight conductor which is attached to a battery. Suppose. Clear this one? This is positive, this is negative. This is what is? This is the straight conductor. Clear this one? So in this case, suppose we will observe, we will take one cardboard here, cardboard like this. That means in this case, this cardboard is entering through this one here. Okay. So in this case, when current is passes through here, so in this case what will happen? See here. So in this case, when current passes through a straight conductor, that means in this case, magnetic field lines are created here. And these magnetic field lines are concentric. That means this center is one and these are concentric. And this magnetic field is very strong at the center and weak towards away. When we will go near to the center, that means in this case magnetic field is very strong, but when we are going away from this center, then these concentric circles are weak. They are far from each other. Clear this one? So in this case what will happen? Suppose in this case the direction is suppose like this, because see here, when current is passes through upward direction, in this case the magnetic field line direction is anti-clockwise. That means in this case the direction of current is like this, anti-clockwise. But when direction of current is changes, suppose we will change the direction of current like this. In this case, direction of magnetic field also changes. That means it is become like this. That means in this case, what will happen? This is clockwise. That means during this straight conductor, when current is passes upward direction, in this case, the direction of magnetic field lines anti-clockwise, and when current is passes downward, in this case direction of current is clockwise. And another thing, the current and magnetic field. This magnetic field is directly proportional to current. When current increases, then magnetic field lines also increases. That means magnetic field lines become very strong. But when current is become low, that means in this case magnetic field lines decreases. So therefore, these magnetic field lines and current, they are directly proportional to each other, but they are inversely proportional. These magnetic field lines are inversely proportional to the distance towards the conductor. So next we will discuss right hand thumb rule. Right hand thumb rule. So what is right hand thumb rule? Suppose this is our right hand. When we will hold one conductor, so in this case our thumb will give the direction of current, and the curve of our finger, which is curved towards here, this finger will give the direction of magnetic field lines. That means in this case also, suppose this is our thumbs, that means in this case this is give the direction of current, then our curve, finger curve, this will give what is direction of magnetic field line. That means this is when current is passing through like this. That means in this case this is anti-clockwise, and when current is passes downward. In this case, what will happen? See here, this is become direction of current. That means in this case, this is gives the direction of current. That means in this case, this is become clockwise. Clear this one? That means this rule and this rule, that is also same for each other. Next we will discuss magnetic field lines produced by a circular loop. Magnetic field line is produced by a circular loop. So what is circular loop? When we will take one conductor and we will draw circle, right? That is, this is become circular loop. So suppose this is the current conductor. When current will passes through here, that means in this case, what will happen? Two ends there will be created magnetic field lines. Here magnetic field lines are created, and these magnetic field lines are, because here, suppose this is upward direction. I am drawing here another figure here. See here, this is the circular loop which is connected to this one. So in this case, what will happen? Here current when passes through here. So in this case, this center circular loops. So concentric circles are created. Here also concentric circles are created. So in this case, you know that when current is passes upward direction, in this case this is anti-clockwise. That means in this case current is passes like this. But when current is entering here, so that means current is passing through downward. So in this case, this is become clockwise. Direction of magnetic field is clockwise. So when the current is entering here, see here, current is entering. That is, in this case, current is entering here. Therefore, when the current is entering at the conductor, that is known as south pole. Then another is known as which pole? North pole. Another is known as north pole. It is also said the magnetic field lines is directly proportional to the current and inversely proportional to the distance of the conductor. These concentric circles are very weak towards when we will go away from this conductor, and when we will go towards the center, that means magnetic field lines are very strong. And the center, the magnetic field lines are parallel to each other. So you should try to understand, and I am giving some notes. That notes you will study, you will learn properly, and if there is any doubt, you should contact me. Thank you.